Hello, Robin. I know that this is for a while that you are working in interference analysis for automotive applications. So, do you have some outcomes, some inputs for us? What happens for interference if we have multiple sensors?
Okay. So in order to get interference, what we try doing over here is we have programmed all of these different EVMs, which is IWR 1843 boost. Two EVMs are for IWR 1843 boost, and one of the EVM is AWR 1642 boost. And we have programmed all with the same configuration. So this means effectively they should build in similar slope interference, and with similar slope interference, as you can see, the output of all of these EVMs is being fed to or can be seen over here on different monitors. And in that case, as you see, or as the gut feeling says, that we should have a very strong interference from all of these three, the mutual interference between these three. So in order to increase the mutual interference, what we have done is we have arranged them on the vertices of a triangle, such that each of their FOV, each of the sensor lies in the FOV of the other. And in this case, as you can see, we don't have a very strong interference in any of the case.
Are they working in similar frequency ranges?
Yes, so actually they're all working in the same with the same bandwidth and with the same slope. The slope of the chirps is the same.
Okay, then why we do not have any interference? Can you explain it?
So the point is, as you can see, that the effective chirping time in every frame is just 20% of the overall duration of the frame. So if the chirping is happening, say for a duration of 15 milliseconds, the frame size is of 100 milliseconds. So the probability of the other interferer to come in the chirping time of the one of the sensor is pretty less. Further, on top of that, because we never capture the data for the whole chirp duration, so now if at all the chirps have overlapped with each other, the amount of beat frequency that will get generated is maybe pretty high, which is not coming in the ADC bandwidth. So that will effectively not get captured.
Okay, I understand. That's why probably since the maximum range is smaller than unambiguous range maybe in these applications.
Yes, correct.
Okay, so that's why. Then what happens if now I guess you said that the tubes have similar slopes, right?
Yes.
What happens if they don't have similar slopes?
Yes, so there was also one of the, in our trials, in the experiments, we tried finding out when the couple or the victim interferer couple doesn't have similar slope. In that case, what happened is the interferer was programmed to have a sweeping type interference with the victim, and what we observed is that there is a strong interference that happens, but the duration for which it happens is momentarily.
Okay.
And in order to, if we see, without doing any post-processing on the data, we do see the increment in the noise floor, and there is a significant increment, and it is as much as a 20 dB increment. But this can be again with the help of interference mitigation technique, which is basically nulling out the samples which are obtained from the crossing type interference. If we do that, we are able to effectively reduce the mitigation, the interference.
Okay, then if we want to use the sensors for indoor application, maybe 1, 2, 3 sensors in a room, do we need to consider any specific, let's say, consideration to consider that?
I think to be on the safer side, we can, if we can do frequency division multiplexing, FDM. But even if we don't do any sophisticated mechanism to get rid of interference, still we don't get to see any interference at all. So I think it is safe to work.
Okay, interesting. Do you publish any outcome of this work somewhere?
Yes, so we have been working for the past couple of months on this topic, and now we are trying to publish this in the International Radar Symposium, which is being held in Berlin. So it will be a virtual conference.
So the paper will be available.
Yes, so the paper will be available soon.
Okay, thank you, Robin. Do you have anything to add?
No, that's it.
Okay, thank you.
Thanks.
Thank you.
Thank
Bye.
you. Bye bye.